different hashing techniques. Generally in data structures, hashing techniques are used to map data or data element or key element to a fixed size value, which can then be used to index the particular data element into an array, which provides efficient data retrieval, searching, insertion and deletion. And here I am going to discuss some common hashing techniques used in data structures, and these are the common techniques, hashing techniques used in data structures. These 8: direct hashing, subtraction hashing, mid square method, modulo division method, digit extraction method, folding method, shifting, rotation. Other than this, many other techniques also are there, like multiplication method, cuckoo hashing, perfect hashing. There are multiple other universal hashing. There are multiple other techniques are also available. Let's discuss these 8 in detail one by one. The first technique is direct hashing. So here in direct hashing, the address is the key itself. The address is going to be the key itself. Here the address, because only from the key element the physical address, whatever the index position, can be extracted with the help of the key hash function, right? So here the address is going to be the key element itself. So the function, the hash function is going to be hashed. Any hash is, you are applying this direct hashing function on any key element, the address is going to be the key only. For example, there are data elements, there is a hash function. I am applying the hash function, to convert the key into the address. For example, I want to store the data element 5, 7, 9. These 3 key values, the data elements I want to store. Here a direct hashing means is nothing but the key element itself is the address here, right? So in a hash table, okay, here it is 8. This is the hash table and these are the indices. Direct hashing means we are going to use key element as the address. So the key element 5 would get stored in 5, the key element 7 would get stored at the index position 7, and the key element 8 would get stored at index position 8. So here the key element itself is the address. So the advantage here is there is no collision. The advantage of using this direct hashing is there will be no collision, especially when the element is very small. If it is in the range of whatever, if it is within the range of our input, there will not be any collision. And there is no algorithmic manipulation, because we didn't use any different complex strategy to generate the physical address. Our hash function is direct here. Whichever the key values, that is going to be the final address for the so and so key element. So there is no algorithmic manipulation in computing the physical addresses to the key element. But the disadvantages of using this direct hashing method, address space should be as large as key value. That is a major drawback. It means if the address size is very huge, if the key element size is huge, if it is the key element consists of 5 bits, if so the hash table, you just imagine the hash table size. So address space should be as large as key value. So it is not suitable for large key values. But there is no collision. The advantage is there is no collision. Why? Because each key value is going to be unique, and we are going to store it in unique memory location only, because the key itself is the address. So there will not be any collision. But the thing is, the address space should be large if the key size is huge. So it is not suitable for large key values. This is how direct hashing would work, and we discussed advantages and disadvantages also, and also we checked how it works also. This is the hash function, and this is our key value, and this is the hash table. Direct hashing is over. Next is subtraction hashing, number 2. Let's check how subtraction hashing function works. Here in subtraction hashing method, a fixed number is subtracted from the key value. A fixed number is subtracted from the key value. For example, I want to compute the address for so and so key value with the help of the hash function, subtraction hashing function. You can use, this is our key value, you can subtract, you can take any fixed number, but same fixed number must be used for all the set of keys. Take any fixed number and that number must be subtracted from the key value, any constant value or any fixed value. This is the hash function for subtraction hashing method. For example, I am going to use a subtraction hashing method, and the key elements are 2960, 2964 and 2962. I want to store inside the hash table with the help of the hashing technique, and this is the hash table. Now let's check where to store all these key elements with the help of subtraction hashing method. So here the key value can be subtracted from any fixed value. Here the fixed value which I am going to take is 2960. You can look at the key values, you can fetch the minimum one out of all these the given key values. The minimum one among these key values are 2960. I am going to consider this 2960 as a constant. So now I am going to apply the hash function. Apply hash function on the key value 2960. If you apply the hash function, 2960 is my key value, my constant is also 2960. So my address location is going, the resultant one is going to be my address location, which is 0. For the key value 2964, if I apply subtraction hashing method to generate the key value, 2964 is the key value minus the fixed value which is 2960. The resultant value is 4, which means the address to store the key value 2964 is 4. Similarly for 2962, apply the hash function on the key value 2962 and generate the address according to the formula, according to the hash function, the address location 2 it is going to generate to store the key value 2962. If so, 2960 can be stored in 0 address location, and 2964 will be stored at address location 4, and 2962 would be stored in index position 2. So this is how the address would be generated with the help of subtraction hashing method. So simple, you can subtract the key value, you can take any fixed value, and that fixed value must get subtracted from the key value. That is going to be the subtraction hashing. That fixed value can be anything without affecting the constraint of the hashing techniques. You can fix any constant number to get subtracted from the key value. The advantage is, it is similar to direct hashing, so no collision. It is similar to direct hashing, so no collision would occur. Disadvantages again, it is not suitable for large data set, for large list. The next hashing technique is mid-square method. Mid-square method is in mid-square method the key is squared and the hash value is obtained by extracting an appropriate number of middle digit. It is one of the most commonly used method for address calculation. The key value is squared and then 2 digits are taken from the mid of the key values. The key value would be squared here. The key value is squared, and the hash value is nothing but the address, and the hash value is obtained by extracting an appropriate number of any number. It depends upon the size of the key. If you want to take one, if the input size is very small, you can take middle 1 digit. If input size is little huge, you can take 2 or 3 or mid 4. Any middle digits you are supposed to take. How many number of digits you want to extract, it's up to you. It depends upon the size of the input. You can decide. If the size of the input is huge, if you want to store multiple number of key elements, if so, you have to take with the 2 combinations or 3 combinations. If there are only 4 to 5 data elements you want to store in the hash table, means you can square it and the middle 1 digit alone can be taken. Why? Because only lesser space is required, so you can take it in a single digit also. For example, let's take some sample example, sample key value, and check with the help of mid square method how the address can be computed. The key values are 5016, 5301 and 5142. I want to store inside the hash table with the help of mid square method. So if you square it, this is going to be the answer. This is going to be the answer, 6025160256. And for 5301, if you square it, you will be getting this. And for 5142, if you square it, you will get 26440,164. Now you can take middle element, appropriate number of middle digits can be extracted. So here I am going to extract the 3 elements, middle 3 elements, 160, 100, 440. So now to store the key value 5016, the address is going to be 160. In 160 physical address, I am going to store the key value 5016. And to store 5301, the address it has been generated is 100. And to store 5142, the address which it has been generated is 440. Which means in these locations, the concerned key values would be stored. And this address has been generated with the help of mid square method. But what is the disadvantage of using this mid square method? Non-uniform distribution of keys, which means the collision. When you place the key value into the hash table, there would be non-uniform distribution of keys, non-uniform distribution of key values, and difficult to calculate the square of large values. That is also another drawback. When the key value is large, if it has the 5 to 6 bits, or if it is a 9 bit, the key value is going to be, it is very difficult it is difficult to calculate the square of large values. Okay, the next method is modulo division method, or division method, or modulus method, you can call it in any way. And this is one of the method which first came into the existence. So here the hash function is defined as hash function of the key value k equals to k mod m. This is the hash function for modulo division method, where k is the key, m is the size of the hash table. This method is simple and effective, but choosing an appropriate value for m is crucial to reduce collisions. This method is simple and effective, but choosing an appropriate value for m is crucial to reduce collisions. So m can be preferably a prime number, then only it would be easy. I'll discuss why this prime number later while discussing some example in the upcoming videos. And the next method here is, okay, let's discuss some example also under modulo division method. Let's take 2 to 3 key values and apply this hash function and check how the address has been computed with the help of this modulo division method. One 1098 1230 2095. These three values I want to store. As I told you before, here this is the hash function h of k equals to k mod m. K is nothing but the key value and m is appropriate values, like some m value which is the size of the hash table. But what should be the size of the hash table? That must be decided properly so that the collision can be avoided. So preferably it must be a prime number, so that when we compute the modulo, the mod value, it would be helpful, and also somehow we'll be able to not completely we can avoid the collision here, because frequently the collision occurs with this method, but always we have to prefer the prime number since we are going with the computing the modulus of each and every the key value. So the key values, these are the key values. If you apply the hash function, the modulo division method, 1098 mod the prime value. So here the closest number here, if you take, that is 1000. The prime value which is closest to 1000, if you check, 997 is the prime number which is closest to 1000, right? Which means the hash table size is also going to be 997. So when you take mod, you have to take mod with the 997 prime value only. So if you take 1098 mod 997, you will get the address 101. And for again 1230, if you check 1230 mod 997, if you perform, you are going to get 233. And for 2095, if you take mod with 997, you will be getting 123. Sorry, for 1230 it is 233 only. For example, again you want to take you want to store a key value 1120. If you take the mod value for 1120 with 997, again you would get, I think, 123. So if you check, these two are different key values, but it shares the same physical addresses, which means it is a collision. So with this method, more frequently we would get the possibility of getting the collision. So the drawback here is, the main drawback of this method is collision occurs. That is the drawback, and this is how the address would be computed with the help of the key value. And this m is nothing but the table size, hash table size, and this must be preferably a prime number. And the next method is digit extraction method. Fifth method. Digit extraction method. In digit extraction method, specific digits from the key are extracted and used to form the hash value, and this method is often used in conjunction with other techniques. For example, let me give the explanation first. A digit extraction means select digits. Selected digits or extracted from the key, and that would be used as an address. The hash function is hash of k equals to some extracted digit. That extracted digit can be anything, and this can be used in conjunction with other techniques also, combined with other techniques also. The same can be, this digit extraction method can be used. For example, these are the key values: 5 3 6 4 5 2. These are the key values I want to store inside. So as the name suggests, it is digit extraction method. Randomly the selected digits are extracted from the key, and that can be used as an address. So it's up to you, like you can extract based on any constraint. The digit can be extracted here. So here I am going to choose the digit which are located at the even position, even the second position value number, second position, fourth position, and sixth position. So the address is going to be 342. So I have extracted the digits which are located at the even positions alone, and that has been used as an address. If you want to use the odd position, also odd positions can be extracted, or if you want to choose some other technique like the mid two positions or mid one position, or only the first position and last position alone, if you want to extract, also can be extracted, and this can be used as the final address to store so and so key value. So there are no constraints in selecting the digit, but if you follow one particular format, the same must be followed for the remaining key values also. Suppose if you want to store around 20 key values, whichever the method has been followed to store the first key value, the same method must be followed for to store the remaining values as well. And the disadvantage here is again the collision occurs, because randomly we are extracting the position. So two different key values or many different unique values may provide the same address, may share the same digits also. So collision occurs. That is the drawback in digit extraction method. Next is folding method. Number 6 is folding method. In folding method, the key is divided into equal parts. If the key length is not a multiple of the part length, the last part may be shorter. So these parts are then added together, and the sum is reduced to fit into the hash table size using the division method, which means key value is partitioned. The key value must be divided into equal parts. Key value must be divided into equal parts. Any parts, it can be any number of parts, not not only like you have to divide it into two halves or three different parts. You can divide as many parts you want. You can divide it into the key values can be divided into many parts, and all those parts must be finally added together, and that sum can be reduced to fit into the hash table size. You can keep on adding it only. Suppose you are getting some 3-digit value, after adding it again, those three can be added, those three values. Suppose 123 is the result you are getting, again 1 plus 2 plus 3 can be added, and finally at the place of 6 it can be stored. At the index position 6 the key value can be stored. Let's discuss it with the example later. Let me write it what it is, what exactly the folding method is. Key value is divided into equal parts. Each part these parts are then added together and the sum is reduced to fit into the hash table size. Now okay, this is the example 100375725. This is the key value I want to store. You just imagine that the address space, the hash table size is 3-digit. It's in 3-digit, the sizes. If so, you can divide, you can partition into equal parts as 3 bits. It's up to you. You can divide it into 4 bits also, 2 bits also. It's up to you. And then you can add now. And whichever the result you get now, that can be used as a final address. So if you add, you would get I think 375 plus 725, it is going to be 1200 we are getting. Then again this can be again subdivided into two, otherwise like once divided, the last two alone can be fetched, or last three alone can be fetched, and that can be used as the memory address. So like again here also there are higher chances of getting the collision. So if you take any hashing technique, there are chances of getting the collision. To avoid the collision, again there are different strategies are there to handle the collisions, that again will be discussed in the in further videos. There are unique strategies are there to handle the collisions. The next method is shifting. Shifting method. Here in shifting method, the digits at both the ends are shifted to appropriate number of positions to generate the suitable relative address. In shifting method, the digits at both the ends are shifted to appropriate number of positions to generate the suitable relative address. The suitable relative address. For example, the key value is 35367312. Now I am going to divide it into segregate into partition into two different halves, and now I am going to add these two. You can follow any technique, but shifting must be, you must have applied the shifting method, some kind sort of shifting must be applied here. If you add it, you will get 80, right? You can exclude the carry, and if you want to shift, it can be shifted also, 0 and 1, right? You can exclude the carry and you can perform shifting now. First and last can be shifted, and if you shift it, 8840 is going to be the address to store this key value. Again, if you want to reduce it, see, it's up to you, like there are no constraints on framing the hash function. Finally, you must ensure that there are no collision and there are uniformly the key must be distributed in the hash table. This is the final, main objective is, without reaching the collision, we are supposed to uniformly distribute the key values into the hash table with the help of any hash function. So you can apply as many hash functions you want into it, but uniformly you must have applied the same techniques for the remaining key values also. So here I have segregated. After segregating it, this is a folding method, right? I have just segregated it. After segregating, I am performing this addition. After adding it, if there is a carry, I am excluding the carry, and then I am shifting the element. First and last has been shifted. If you want, first and third also can be shifted, or second second element and last before element also can be shifted. Some sort of shifting you are performing, you are doing, and then the final address has been generated here, 8840. And the next hashing technique is rotation method. Here the last digit of the key is rotated to the left side. Like again, it's a rotation in the sense shifting only, kind of shifting only, but directly we are performing the rotation here. Last digit of the key is rotated to the most significant bit of in the left side. So it is most useful when keys are assigned serially. This method is going to be the efficient one, preferable one, when the keys are assigned serially. Example, key values are 70101 76025. Here we are performing the shifting, the rotation here. Rotation means I am just placing the last digit of the key. This last digit is rotated here. This would come here and this 5 would go there. The resultant number is 17010. If I rotate here the last bit to the most significant bit in the left hand side, I would get 57602. This is the address in which we are going to store the key values. So these are the different hashing techniques are there in data structures. Other than this, many other hashing techniques are also there, like universal hashing, multiplication method, then perfect hashing method, cuckoo hashing, like this. Like there are multiple techniques are there. We are supposed to prefer the best one which reduces the collision, because we can't completely avoid the collision, which you have to choose a method. You have to prefer the hash function which reduces the possibility of getting collision, and which ensures that there is a uniform distribution of key elements in the hash table. Thank you.